Assalamualaikum warahmatullahi wabarakatuh. Nama saya Hazi. And today I'm going to explain about section 1. So in this section, Assalamualaikum warahmatullahi wabarakatuh. My name is Hazi, and today I'm going to present about lab 4, DC high voltage measurement and monitoring. So objective of this lab is students should be able to construct parallel DC high voltage measurement using kit control 4.0 and picoscope 3000 series, and familiarize the procedure for setting DC the kit control 4.0 and picoscope 3000 series. And lastly, compare and analyze the DC value obtained from kit control and reference and picoscope 3000 series display. So I'm gonna explain for section 1. Section 1 is a construction of parallel DC high voltage measurement using FC and picoscope. So what I need to do, you are required to rearrange similar picture as shown in figure 1 and figure 2, both adapt from lab 3 for parallel DC high voltage measurement using FC and picoscope. Name the new arrangement of the new figure as figure 3. Next, draw a complete schematic circuit of AC and DC. Finally, you have to take into account the connection of braided copper cable from floor pedestal that holding 100 picofarad and secondary unit for AC, and also floor pedestal that holding 280 mega ohm and secondary unit for DC. Suggest the safety rule action that need to be concerned at the earthing switch and clean testing layout. Now, this is figure 2. We can see that this is already done in lab 3. So I'm going to share my section 1. Okay, in section 1, this is a figure 1, which is connection of AC high voltage measurement. So in section 1, the figures show that we are using in figure 1, I'm sorry, I'm going to share my section. So as we can see in figure 1, the figures show that we are using kit control 4.0. Figure 1 consists secondary unit AC measuring capacitor 100 picofarad, adapter A, adapter B, BNC T junction, picoscope and frequency converter. Measuring the capacitor 100 picofarad need to be connected to adapter A. Then after the connection on the adapter, the output of the adapter A will be connected to the secondary unit AC. Next, the output of the secondary unit AC will be connected to adapter B. The adapter B will be connected to the T junction. One of the output of the T junction will be connected to FCBN1, and the other output of the BNC T junction will be connected to picoscope. For the earthing system, measuring capacitor will be connected secondary unit AC of the ground connection. And lastly, the copper braided connected to the secondary unit AC and measuring capacitor 100 picofarad. And for the figure 2, you can see here, this is how the arrangement for AC and DC high voltage measurement. So in this figure, contain 100 picofarad, spacebar, high voltage diode, insulating support, parallel resistor 2.4 kilo ohm, smoothing capacitor 25 nanofarad, measuring resistor 280 mega ohm, grounding copper braided, and SCH high voltage measurement. Okay, for starting, the 100 picofarad is for the AC high voltage measurement, and then the 100 picofarad will be connected to the connecting cup. Next, after the connecting cup, will be connected to high voltage diode 100K, and the AC and the high voltage diode 100 kilo ohm will be functioning as a rectifier. We use two high voltage 100 kilo ohm. The high voltage diode is the green color, and the other side of the 100 picofarad, as we can see here, the 100 picofarad is over here. So the other side of the other side of the 100 picofarad will be connected to the floor pedestal. So from here, connected to floor pedestal. At the same time, will be connected to spacebar. And then spacebar, the end of the spacebar will be connected to other floor pedestal, followed by connecting to insulating support. The other end of the insulating support will be connecting to connecting cup. Clear ke? Okay. From connecting cup will be connected to other high voltage diode. The end of the high voltage diode will be connecting to other connecting cup. Will be connected to parallel resistor 2.4 kilo ohm and other space bar, and followed by smoothing capacitor 25 nanofarad. The white one. Next, the end of the smoothing capacitor 25 nanofarad will connect to the floor pedestal, followed by connecting spacebar. At the end of the connecting cup, this one will be connected to measuring resistor 280 mega ohm and the end of the output of the measuring resistor 280 mega ohm will be connected to spacebar of the floor pedestal. So floor pedestal will be connected to DC voltage, this direct current high voltage measurement, which we have been in lab 3. So for grounding copper braided, we connect to every floor pedestal that we have, that we using in this connection. So for safety feature, I think we need to make sure the cable is connected properly. Next, arrange the cable so that no crossover happen. Last, make sure to keep the equipment to original place in the lab. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazid bin Hisham. Now I will present about section 2, configuring the procedure of setting the kit control and picoscope. Kit control 4.0. There are 4 features and functions in kit control 4.0 that be highlighted. The first part is source control. Second part is primary side of the transformer progress. The third part is system monitoring of secondary side of the transformer with 8 slots. And last part is alarm system. Now we go through the first part of kit control 4.0, which is source control. The source control acts as the input source control. The value of source control can be set in customer setup, which labeled as manual step. Each button has a feature of its own. Source control is used for either small gain or significant gain to increase or decrease the value. Now, the second part is primary side of the transformer progress. Primary side of the transformer progress is another feature that is illuminated in kit control 5.0. Under source controller, this element is shown. The primary of transformer progress is voltage and current display. Other than that, system monitoring of secondary side of the transformer with 8 slots also a feature in kit control 4.0. This monitoring of the device consists of 8 slots. The frequency converter terminal links these slots, which is VM1 to VM6. For each terminal VM1 and terminal VM2 are attached to 2 slots in kit control 4.0. Another 4 slots for each one are connected to the 4 terminals, which is VM3 to VM6. In the experiment, terminal VM1 and VM3 are used. Terminal VM1 indicates for AC measurement, and terminal VM3 shows measurement for DC value. The S slots are used for the results of the display measurements. The last feature in kit control 4.0 is the alarm system. The alarm system is used as a safety precaution step to prevent the occurrence of any unexpected incident. When the alarm is red, it means that there is a problem, such as pressing the interlock or emergency button. The system will not begin if the problem has not been solved. So, select the reset button in kit control 4.0 to clear the warning reset when all the problems have been solved. The machine can only work when the alarm is in green color. So before we run the measurement, we need to apply a proper setting of customer setup, which requires some configuration of calibration in calibration section. In calibration section, we need to insert the divider ratio of secondary capacitor AC in the first slot, which the value is 196,651.1. That is for AC calibration measurement. Then we insert the divider ratio of secondary resistor in the fifth slot, which the value is 20414.4 for DC calibration measurement. After that, we need to tick the first and fifth slot to active the slots measurement. For the picoscope 3000 series configuration, there are several sections needs to be configured. Association sample sections are used to determine the number of samples that are needed for the experiment. There are 4 channels in picoscope, which are channel A, B, C, and D. These channels are displayed in picoscope 3000 series. To determine the accuracy of the data, the sample interval section may adjust its value. Select and active the required channel in order to use it to display the data in picoscope, which for the experiment, we need to active the channel A and B. The coupling can be either AC or DC. The coupling Set the coupling AC for channel A and coupling DC for channel B. The range can be set from 20 mV to 20 V for picoscope 3000 series. The important section in picoscope 3000 series is the divider ratio. So we need to insert the divider ratio value of 19651.1 because the divider ratio of secondary capacitor AC that being used in the experiment is 19651.1 in channel A. In channel B, we insert the divider ratio value of 20414.4 because the divider ratio of secondary resistor that being used in the experiment is 20414.4. In order to set the x-axis to begin at a value of 0, the offset value is typically 0. The channel activation can be switched easily in the data log section, and the type of coupling that needs to be used can be calculated. To begin a new measurement, we just need to press the reset button. That's all for me. Thank you.
Assalamualaikum and good morning. My name is Nusrada binti Zaidun, and I will explain about the section 3 for lab 4 DCI voltage measurement and monitoring. Firstly, we are required to construct the table of comparison between result of reference from the key control and also the result from the display that was obtained from the picoscope. Basically, this is the table of data that was been obtained, and then the percentage of error was calculated. The percentage of error is calculated with reference voltage minus display voltage divided by reference voltage and then time by 100%. Next, we need to make a discussion using the data provided. Based on my discussion, there is a discrepancy between reference and display reading based on calibration fact. Usually, the reference results are often assumed as either value, X and Y used to estimate the accuracy of the display result. Digital display reading always limited to decimal value, and that was one of the reading might be differ a bit from the reference value. The accuracy of the value is the closeness of agreement between a measured value with the accepted value. Meanwhile, precision of the value is the reliability or reproducibility of the result. And lastly, the discussion, the conclusion for the lab 4. A conclusion was made regarding on the experimental lab session related to the sensitivity range of scope and coupling setting. Based on my calculation, in the range setting, it was set to auto range and the coupling setting was set as DC. This factor might be one of the reasons why there is a discrepancy between the reference and display reading, as there might be difference of value due to resistance effect. The sensitivity range of scope and coupling setting, vertical sensitivity indicates how much the vertical amplifier can amplify a weight signal. Hence, DC coupling was used as it allowed to see all the signals from the minimum until maximum bandwidth of the scope. That's all from me. Thank you.